looky there, that's the first answer. It's the reflection of the line y equals x. Okay, and if you looked at some of your graphs in here, you didn't do that.
If I could do it, will you stand up?
I'll think about it. Okay, now, if the point, guys, come on. Here's what I wanted you to do. If the point a comma b is on the original, what point would be on the inverse? Okay. Okay, so when I asked you to graph y equals 2 to the x, y'all could have done that, put it in your calculator, do it by hand, I don't care, but you should have had a nice graph on the paper. Not to mention that we've done that one a couple of times over the last 6 months. Okay, that's your parent function for exponential. We're going to use y equals 2 to the x as the parent function. All right, so in general terms, the domain of the original function is what for the inverse function? The range. All of this is review. Now, for an exponential function, there are 2 points that are going to be on every single one that you graph for me. And that is, if x is 0, what's your y value going to be? 1. Do we all know what's anything raised to the 0 power?
1.
That didn't sound really definite. Do we all know that anything raised to the 0 power equals 1? I just taught it in Algebra 1, so don't act like you've never seen it before. Okay. Yes, I teach Algebra 1. So, the other point that you're going to show on every single graph is if x equals 1. Now, if I plug 1 into there, what is my y value going to be? Let's not overthink this. If I plug 1 in here for x, what is this going to simplify to? A. So you're always going to have the point 1 comma the base. Little review here. We know that A is the base, right? A is the base, X is the exponent. Now, based on my graph or your graph, whoever's correct, the blue one is the exponential. Where's your asymptote? At the x-axis or y equals 0. So the x-axis is a horizontal asymptote. Exponential functions are going to have horizontal asymptotes. And if you want to put it in there, we'll say y equals 0. That's our starting point. What's the domain of the exponential function? Look at the graph. Negative infinity to positive infinity. And what's the range of the exponential graph? 0. Okay, 0 with a parentheses or a square bracket? What's the difference?
It never touches 0.
It never touches 0. So 0 to positive infinity is our range. Okay, this is one of the truly totally new things. You have never seen logs before. Probably. I mean, maybe somebody has at some point, but this is not something that I would expect that you've ever seen before. Okay? Now, the best way I can explain this is when you were a little kid, you were taught how to add, right? And your teacher, your parents, or whoever said, well, if you have 3 markers, and you have 1 marker, if you put them together, you have 4 markers. And you're like, oh, I get it. Okay? And it took you a while to figure it out, but you learned how to add, and then you learned how to multiply, and then you learned how to subtract and divide, and you learned all your operations, and you went from there. Well, I'm telling you, the log function is like an operation. And it's something that you're going to have to get used to. All right, it's not going to be automatic, but you will get used to it. It's really not so bad. I am telling you, what's the inverse of addition? What's the inverse of multiplication? What's the inverse of exponential? Okay, so it's a function on its own. It's the inverse of an exponential. It's all going to get tied together. Just stick with me. So, since it's the inverse, if I have these points on my exponential, what do I have on my log function?
1, 0, 1.
Okay? That's why you have to understand exponential to understand log. Now, if the x-axis was the asymptote for the exponential, what axis is going to be the asymptote for the log? The y-axis. And what am I going to do with my domain and range for the log? Switch them. So my domain is going to be 0 to positive infinity, and my range is going to be negative infinity to positive infinity. Those are your general guidelines for your log functions. Okay? All right. Let's get a little more understanding here. All right. We're just going to make some up. Let's put down our 2 to the x, which is what we're going to be using as our parent function. Give me another number.
7.
Oh, okay, we're going to have 7 to the x. There's an exponential function. Sam, give me another number. 5. 5 to the x. There's another one. Okay, now we're going to have the common ones. We happen to live in this country that measures things differently than pretty much the rest of the world. We have a base 10 system, yes? So, f of x equals 10 to the x. That's a really nice one because we know how to raise 10 to powers by adding its zeros, right? Makes it kind of big to grasp though, so it's there. Now, there's a special one. There's a special one. E to the x. Now I know. You're going, E, what's E? Ah! You just, I'm going to go out on a limb and say that last year, you all used pi extensively, right? Coming up to Pi Day in what, 13 days, right?
Are we going to celebrate Pi Day?
Yeah, I don't know about that, we'll see. I don't know about that. I don't think it's a B day. I don't think so. Alright, well let's see. Alright, hold on. Okay, so, you guys learned what pi was, right? And maybe you did some sort of description of how pi was created, how they came up with pi. But what you realized was that pi was, no? No? You don't know what pi stands for?
It's the diameter.
The diameter of a circle.
It's the circumference divided by.
It's summary.
Circumference of the circle divided by the diameter. Okay, so whether you remember that or you remember 3.14, the bottom line is that you found that pi as a number was very useful for a lot of things, right?
Yeah.
Well, guess what? There's another one. And that's that little letter E. Why am I not getting the calculator? Okay, E. Look on your calculator and find E. I don't know if I can get... Oh, come on.
Oh, not the letter E.
No, not the letter E. We want the funky kind of E. Oh, this is not going to be E. Alright, I seem to be having calculator issues up here, but did we find the E?
Yeah.
It's second and the division sign, right?
Yes.
Second and the division sign. Now, push it. It's some big, ugly, irrational number, right?
2.7128.
Second, and the division sign.
Is it repeating?
Yeah.
No,
Is it
I-
repeating?
It's not.
I believe it's irrational.
It says 2.7, 182,
128.
I'm gonna have to check that one out. Okay, well, we all found where E is on the calculator, yes? Okay. Now, unlike pi, you're not gonna memorize E to 2 or 3 places. We don't really use E as a number, but you have to know where it is and you have to know that it's something that we're gonna need. Okay, so, evaluating functions. Where do I put this -1? If I'm looking at this function here, where do I put this -1? In the exponent. So what is 3 to the -1 power?
1/3.
Oh, thank you for remembering that. And what is 3 to the 3rd power? 27. What is 3 to the 3/2 power? You all have a calculator. Rounded to how many places?
5.1.
Rounded to how many places? 2 places. That's my rule.
5.3.
5.2. Or 20, whatever you want. And how about 3 to the 3.61 power? What do we get?
52.77.
Okay, 52.77. Okay, so exponents are a piece of cake, yes? Not a problem. Okay. Now, parent function. We said that you're always going to have x equals 1 and you're going to always have x equals 0. What else do we want to use here? We want it to fit on here. -1. What else do you want to use? 2. Okay, so 2 to the first is 2. 2 to the 0 is 1. What's 2 to the -1 power? 1/2. And 2 squared is 4. All right, so we've got 1, 2, 0, 1, -1, 1/2, and 2, 4. There's our points. Here's our graph. And please do not forget to put the asymptote in. Make sure you have all parts on the graph. We okay? All right. 5 to the x. Again, we want to have 1. We want to have 0. What other numbers do you want to pick? -1. What else?
2.
Is 2 going to fit on our graph?
Probably not.
Probably not. So maybe we'll pick something else. -2. All right. 5 to the first is 5. Anything to the 0 is 1. What's 5 to the -1 power? 1/5. What's 5 to the -2 power? 1/25. Right? So we have 1, 5, 0, 1, -1, 1/5. 1/25, best you can draw it. Your graph goes pretty steep. Make sure you've got arrows on the end. And again, we have an asymptote on the x-axis. Next one. Well, we know we want 1 and we know we have 0. Anything to the 0 power is 1. Anything to the first power is itself. What you got?
Wait, can we use
Oh.
calculators?
Yes. Yes. On the test, there's going to be some parts that you can't use a calculator for. And as we go through the unit, I'll tell you things that you ought to be able to do without a calculator. But right now, we're just investigating, so by all means, use a calculator. Anybody find a point for us that's going to fit on here? -1. Oh, look at that. -1, 3. That doesn't fit, so
So 2.
2.
2. Okay, 2. And what would that be? 1/9. Knew we could do this. Okay, so 1/3, 1, 2, 3, 2, 1/9. And our asymptote is still the x-axis.
And you
Now,
know the asymptote is because you can see the curve go like not touch it, like go just go.
I hate to agree to that because yes, in these cases, but by the time we're done, you should know where your asymptotes are just because it's an exponential function. Because we're going to start doing transformations, so we're going to start moving the asymptote around, and you should, ideally, you should know that based on your transformations, not just because, oh, that's the way it looks like on the graph.
Right.
Okay.
Because it's not like collapsed whenever it's like in the equation.
No, it's from the parent function. Okay? All right. So, I do want to talk about this one. Anyone know what the transformation is here from reflect over the y-axis? Do we know why? Like, how else could we write this to show the reflection over the y-axis? How can you write 1/3 not as a fraction? No, not as a decimal. Not 1/3. I don't want 1/3. What I'm looking for is I'm looking for f of x equals 3 to what power? The negative x power, right? To bring the 3 up to the top, you would change the sign of the exponent. Sidebar. If you have, we just did this in algebra 1, if we have 2x squared y to the negative 3, isn't that 2x squared over y cubed? If you have your negative exponent, you move it, yes? So if I have in the bottom 3 to the first power, if I move it up, it's going to become 3 to the negative 1 power, right? Every time you cross the fraction bar, you change the sign of your exponent. Oh yeah. All right, and I know we haven't done a lot of reflection over the y-axis so far this year, but we did talk about if you have a negative in front of your x, there's your reflection over the y-axis. And the reason we haven't done many is because if you think about your absolute value equation, if you reflect over the y, does it do anything?
No.
No. So it's not really worth talking about reflecting over the y-axis when you're talking about absolute value or even quadratic. Same thing, if I reflect it, it's going to look the same. Okay? So now's the first opportunity we really have to make it look like something when you reflect it over the y-axis. Okay? All right. Let's take a look at logs now. Here comes the new stuff. You ready? You ready? Yes, you are. Okay, so let's start with, to read this, you would say y equals log base A of x. That's how you read this function right here. All right, just like our exponents have a base, our logs have a base. And your base is your base is your base. It's always the thing down at the bottom. All right, so some examples. Well, we could have log base 7 of x. We could have log base 61 of x. Right? Yes.
Is it always supposed to be 1x, or could it be like log base 7 of like 2x?
Oh, there's all sorts of stuff for integrators. Yeah, all sorts of stuff. Okay, now, guess what? Good old Americans, log base 10 of x. Well, again, we love 10, right? Makes life easy. But just like when I write the x here, isn't that the same thing as 1 times x? But we don't put the 1 there because you all know it's there, right? Well, they're going to expect you to know base 10. They will never write log base 10. They will just write log x. If there is no base written, it's base 10. Okay? If there is no base identified on your log, it's always going to be base 10. Okay? Any book you look at, any worksheet, any test, they're not going to put the 10 there. You need to know that it's a 10.
Should we put the 10 there?
If you want to, you can. I mean, doesn't hurt. If you look on your calculator down the left-hand column, you've got a log button, right? That's log base 10. That's what they're giving you on the calculator. Now, there's a special one. Here we go, log base e of x. There's that lovely e. They will never, well, I can't say never. Occasionally they might write that, but what they call it is, that's an ln. This is called the natural log. They're not usually going to say log base e. They're just going to write ln. And you need to know, it's like learning vocabulary. You need to know that if they write ln, that's log base e. Okay? Because as I said, just like pi, e does a lot of things in upper level math. And so rather than writing log base e, they just call it a natural log. Okay? All right, now let's talk about what this means. This says, starting at your base, what power of 3 is going to give us the x value that we're looking for? So here, this is going to say 3 to what power equals 9? Because this is our x in here, right? So 3 to what power equals 9? There's your answer. Okay. So here, 3 to what power equals 3? 1. And 3 to what power equals 27?
3.
And 3 to what power equals 1?
0.
Oh, that wasn't so bad. Right? Now, I'm going to teach you a lot of different ways to do this. This was just the figuring it out. Okay? Common sense in this unit will take you a long way if you have common sense. High school students, I don't know. Well, then you're going to have to do the mathematical way. Forget the common sense, just do it using math. Okay, so now, we just said that the log is the inverse of the exponential, right? So flip over the other page, and what are the inverse of the points we found? 2, 1, what else? 1, 0, what else? 1/2 negative 1, and?
4, 2.
4, 2. Okay? So, we're going to go ahead and graph those. 2, 1, 0, 1/2 negative 1, 4, 2. Our graph looks like this. And we have an asymptote on the y-axis. Go ahead and do the inverse of the other two.
Yeah.
Oh, thank you.
All right, do we have our graphs? They look like this, hopefully. Yes. All right, let's do some transformations. Look at what it says at the top of the next page. This should be very familiar to you. These are the same transformations that we've been doing all year. All year. What does the A out front do? Circle, stretch, or compression. What does the number next to the X do? Left or right? What does the number outside by itself do? Up and down. Same thing, guys. Whether it's an exponential or a logarithm, it's going to do the same thing. So, parent function, we just graphed this. Should take you 2 seconds to put it on the graph again. Alright, there's our parent function. Y equals 2 to the x. Now, for the first one, what's our transformation? Down 3. Right here. Right here we've got down 3. The first thing I recommend you do, and this goes back to your question earlier, the first thing I recommend you do is move your asymptote. Okay? So the first thing I would do is I would take my asymptote from the x-axis and I'd move it down 3. So I got my asymptote set. Okay? And then you have choices. You can draw your graph relative to your asymptote, or you can take your parent function points and move all the points down 3. All right? Because I'm looking here and I know from the origin I go up 1 and there's a point. So from the intersection of my asymptote and the y-axis, I know I'm going to have a point there. I know my next point is up 1 and over 1. I know my next point is up 3 and over 2. Back 1 and down 1/2. So it doesn't matter. If you want to say, if I take this point, I move it down 1, 2, 3, oh, there it is. If I take this point, 1, 2, 3, oh, there it is. So that's why I'm saying, whether you want to do it relative to your asymptote and your y-axis, that's fine. If you want to take each of these points and just move them down 3 places, that works also. It's up to you how you want to draw it. Make sure you put the graph in, make sure you've got the arrows on the sides, on the ends. All right, next one. What's our transformation? Left 1. So, if I go left 1, is that going to change my asymptote? No. So I'm going to go ahead and put my asymptote in. And I'm going to take all my original points and move them left 1. So I know I had one here, I'm going to go left 1. I had 1, 2, I'm going to go left 1. I had 1, 2, 1, 2, 3, 4, I'm going to go left 1. The more you do this, the more comfortable you're going to become with this. Okay, so make sure you practice these things. Practice your parent function so you know what you're doing. And then we can go ahead and draw it in. Alright. Next one, what's our transformation? Up 2. So again, the first thing I would do is I'd move my asymptote. And I'd take all my points and move everything up 2. So from here, I go up 2. From here, I go up 2. From here, I'd go up 2. And from here, I'd go up 2. I got my points. I can draw my curve. Next one. Oh my. What's your transformation?
Across the y-axis.
Reflect across the y-axis. Okay, reflect over the y-axis. Well, is that going to change my asymptote? No. Is that going to change my y-intercept? No. But now, instead of having a point here, I've got to put it over here. Instead of having a point here, I've got to put it over here. Instead of having a point here, I've got to put it over here. Now we have a reflection over the y-axis. That looks like that. And if you're not sure, since at the moment you have a calculator, y'all know how to type this in the calculator? Get a negative x exponent? You could do that. Or to do it in the calculator, you would do 2 and then the up arrow, and then put in your negative x. Okay? Alright, you ready for some logs? Sure you are. Sure you are. Alright, everybody get the parent function for logs on the paper. See if you can do it. Maybe without even looking. Maybe. Yep.
What's the minimum amount of points you want on this graph? Like 4?
Yeah, like 4. I mean, unless it's some huge number, but 4 is probably good. Do we have our parent function okay? Yes? Okay, so what's our first transformation here? Up 1. Now, if you go up 1, is that going to change your asymptote? No. So all we're going to do is take all of our points and move them up 1. So from here, I'm going to go up. 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 And the graph looks like that.
Wait, so there's no change?
There is a change, you just can't see.
What do you mean no change?
It looks like,
Exactly.
oh,
This
it's,
point-
oh, it's no, oh, okay.
Yeah. Okay, you know, usually a lot of times it's easiest, it's hard because it's not, or I can't do it to 10, but it's easiest if you look at your intercepts maybe. And the last one, what's the transformation? Right 3. So the first thing we're gonna do is move our asymptote, which kind of makes us fall off the graph, but we're good, so we can handle that. So I'm gonna have this point, and this point, and this point, and this point, right? We kind of okay on the graphing so far? All right. Now the fun starts. I mean, graphing is okay, but solving equations, that's kind of what algebra is all about. Solving equations. Okay. Right here, the key concept. The bases must be the same on both sides of your equation. Okay? Well, I have a base of 4, right? So I have to rewrite 1. This is 4 to the 2x plus 3 equals 4 to what power? 1 equals 4 to what power? 0. We okay? Anything to the 0 power equals 1, right? Okay, so guess what? If your bases are equal, your exponents are equal. So all we have to do is solve 2x plus 3 equals 0. If your bases are equal, then your exponents are equal. Oh, this is great! Right?
Yeah.
So what does x equal?
-3.
-3/2. Okay, oh look at number 2, they already give you equal bases. So set up your equation and solve it. Let's see what you get. What does x equal?
3.
See? You all thought this was going to be hard, didn't you?
I guarantee it.
Okay, good thing we have a calculator. So 3 to the 1 minus 2x equals 3 to what power is 243?
Fifth amount.
You have a calculator, no reason to grimace, just guess.
You did it. It's the fifth power.
Yeah, okay.
You just read it.
I don't know where you played with this calculator, right? 3 to the 5th. Oh, okay, well that means that 1 minus 2x equals 5. I can do that. But I'm going to let you do it.
You're so funny.
So what does x equal? -2. Okay, solve the last one. So a equals 0. Okay. A huge key to this unit is being able to rewrite from exponential into log and from log into exponential. We started way long time ago where we said, oh, well, if you have y equals 2x plus 6 and you want to find the inverse, you say x equals 2y plus 6 and you go from there, right? Okay, so the Nike switch is what you're going to do to rewrite it from a log to an exponential. And this is what you're going to do. As I said, your base is your base is your base. You always start at the base because it's at the bottom. There is no one here, I don't think, that was born at the top of the hill. Okay? No one here was born at the top of the mountain. You always start at the base. You go skiing, you start at the base and you go up. Okay? So, we are going to start at the base, and you're going to draw the Nike swoosh. Don't comment on my drawings. As I said, this is why I don't teach geometry. Okay? You are going to draw the Nike swoosh. So, to rewrite it as an exponential, when you write it as an exponential, I had better not see that word log anywhere in there. Okay? Because if you write the word log, then you're telling me it's a log. So, to write it as an exponential, you start at the base. This is what you do. You said 6, follow your swoosh. Raised to the second power equals 36. That's it. 6 raised to the second power equals 36. That's it. And that's true, right? 6 squared is 36. Okay? Over here, to our swoosh. So we have 289 raised to the 1/2 power equals 17. Check it on your calculator. What's a 1/2 power? Be smarter than my fourth period. What's a 1/2 power? Thank you. There's a little hesitation for the period. Yes.
Can we just like leave it like that?
Yep. All this asks me to do is rewrite it.
Are they always gonna work? Or should we
Yes. They should always work. Number 3, we're going to have 14 to the negative 2 power equals 1 over 196. Check it out.
Wow.
Yes? How about that? Okay, so the last one, we have 3 to the 4th power equals 81. Beautiful. Okay? And guess what? It works the same in reverse. If you're going from log, like, you don't know what log base 2 of 4 is, do you? You've ever heard of log? Can you do log base 2 of 4?
Yeah.
Put that calculator down. Okay, so anytime you are stuck in this unit, swoosh it. Okay? If we swoosh it, we get 2 to the x power equals 4. Oh, wow. So hard. What does x equal?
2.
Right? Right here. Swoosh it. 3 to some power equals 81. Well, what does the power have to be? 4. 4. Oh, rolling now. Do the last 2. Let's see what you get.
I'm never gonna get any hours for that.
No, but I'm giving blood. I'm working hours, 4 hours.
Yeah.
I don't need one.
No, you think you did.
Your base is 4.
I have to figure your
4 should be,
16 to get blood.
it should be 4 to the 4th power, not 3 to the 5th power.
I want to do it too in the general.
Okay, so,
Why? I'm basically.
just to finish up, B is going to be 64, and X is going to be 0.